Hello there, welcome to this new lecture in which we are going to see how to implement the binary heaps. So if we recall, these are the basic operations we have already defined, which is computing the length of the queue, its minimum value, to remove that minimum value, also of course making into account that to trigger an exception when the queue is empty, heapifying from a position, that is swapping from that position down to preserve the heap property, adding values to the queue, and building a heap from a list. So first of all, what we're going to do is introduce our class minheap, which has the following structure. The constructor of the heap only contains a data list, which is the list in which we will be representing our heap. As already mentioned, the length value will be done just by overwriting the standard length method for classes, and it's as simple as just returning the length of the list. Computing the minimum value is also easy because it's always the first position of the list, and the only thing we need to check is that the list contains a value. Otherwise, we will raise an error indicating that the min heap is empty. The next method we are going to implement is how to removing the min. Remember that removing the minimum value is not only getting the value out of the heap, but we also need to heapify from that position. More precisely, what we do is first ensure that the heap is not empty. If it is, we raise an error. And then we compute which is the minimum. In this case, we store it on a variable, the value. We remove that one and we place it, and we store the value because we need to return it at the end of all. And remember that what we do is we check for the last element of the list. That's why we are making that pop to get that element and place it as the new root. Of course, we need to take into account that it has more than one element. If it is, then we just simply put the new root as what it was the last element, and we heapify from the root. That's it. We make a call to the heapify method from the position 0. And this will be restored the heap property, and then just we will need to return the value. Therefore, the next method we need to build is the heapify method. Because remember that we are always heapifying from a position. So for simplicity's sake and making the code less large, we are going to use an auxiliary variable just to represent the list containing the data, and also the size of the heap, that is the length of that heap. So remember that when we are heapifying from a position, what we are checking is if that element is not a leaf. We check for its two childs, find which is the smaller child, and we compare to its parent to see if we need to swap positions. So in this case, that's what we're doing. We find which is the smaller child, And in case that child is smaller than its parent, we swap positions and then make the recursive call to heapify. Because in this case, remember, these are recursive function, and the base case is when the element is a root. That's it when there are no childs and does not enter inside this if. Adding positions, adding new values into the heap. Remember that what we do is add at the last position, and then from there check the parents to see if we need to make swaps. So again, just for clarity's sake, we add the new value at the bottom of the tree. Since we are representing the tree with a list, it's just making an append to add the new value. And what we do is compute which is the position of that element to find its parent. We find where the position of the parent is, and then we check. As long as the child is smaller than its parent, then we will make a swap and check again. This will be repeated either as the child is smaller than the parent, as I was mentioning, or once we find the root. If the position is already the root, then we are done. The next method is from building a heap. Remember that we are building a heap from a list. So in this case, what we are assuming is that, let me go back, that our self data, instead of being initialized as empty, it will be initialized with the list we want to transform into a heap. So calling build heap means altering the data to maintain the heap values. Of course, we will do this only if there's more than one value. Remember, when building a heap, leaves are already heaps, and what we need to find is the first element that is not a leaf, and from that position going backwards level by level until the root, and heapify from that position. So in this case, if there's more than one element, otherwise it will already be a heap, we find the index, we find its parents, and we're going to, that it's the last parent, means the first node that needs to be heapified, the first node that is not a leaf that needs to be heapified. And what we're going to do is as easy as from that position going back to the root, since it's a list, just going from that position backwards, just going from the position and simply means one, and just we're going to call to the heapify function. If that position would be already be a leaf heap, then the heapify will maintain as it is. Otherwise, it will swap its positions as needed. Once the loop has ended, then we have finished. That's all. Thank you.